Alright, this question we're going to take the momentum and the impulse one step further. This question says a bat strikes a .145 kilogram baseball. Just before impact, the ball is traveling horizontally to the right at 50 meters per second. So let's suppose this is the ball here, and it's traveling to the right at 50 meters per second. Then it leaves the bat, so here's the bat, and it leaves the bat and it travels now at 60 meters per second at an angle of 35 degrees. So the ball weighs 0.145 kilograms, and the bat and the ball are in contact for 1.85 milliseconds. And the question is, find the average force in the x direction and average force in the y direction for this scenario. So before we even find the force, we have to go back to impulse. And you might remember the impulse is the change in momentum, P2 minus P1. And the momentums are really the mass times velocity. But because this has an angle, we're going to have to split up my impulse into two impulses, into the x component and y component. So let's think about the x component. The x component of the impulse, therefore, would be, let's go right to the mass volume equation. So the x component of the impulse will be m times the second velocity in the x direction minus m times the first velocity in the x direction. And in this case, well, the mass is constant at 0.145, so we can actually pull that out of the equation. And with the second velocity now in the x direction, that's the key. The velocity in the x direction, if we think of this direction in the standard coordinate, this direction as being positive, and the left direction is negative. So the second velocity is actually negative. And what is it? It's 60 meters per second, but we only want the x component, so we have to take a cosine of that 35 degree angle. That is v2x, and then minus v1x will, and it's actually negative, so let's put a negative here. And v1x, mv1x is going to be, well, v1x is going to be 50, and it's totally horizontal. So if we work that out, remember the negative here, if we work that out, that works out to be negative 14.38 kilogram meters per second. Now that's Jx. The question asks you for the average force. Well, you might remember the force that the actually impulse is equal to force times the change in time. So therefore force is equal to impulse over the change in time, over the duration. So F in the x direction, the average force in the x direction, let's call it average, is equal to the impulse in the x direction, because you can do this for either x and y, so it's equal to Jx, x direction, over the time. If you solve this equation, if you look at this equation here, that's what it says. And so that's Jx, negative 14.38 kilogram meters per second, divided by a change in time is 1.85 milliseconds, which is 0.00185 seconds. So we're going to have our units of kilograms meters per second squared, which is units of Newton. And if you calculate this out, we get 7.773 kilogram meters per second squared, or newtons. So that is the force in the x direction. Now let's find the force in the y direction. The force in the y direction, we can call that, first of all, we need to find the impulse in the y direction, so Jy, and that's equal to mv2 in the y direction minus mv1 in the y direction. Well, m again stays the same as 0.145, and the velocity, the second velocity in the y direction, now that's the y component, this vertical component, well, that's the sine of 35 times 60, so that'd be 60 sine of 35 degrees. And then the velocity, the initial velocity in y component, well, that's 0 because all velocity initially is all horizontal. So that's 0. So if you work that out, that works out to be 4.99 kilogram meters per second. And then if you want the force in the y direction, the average force in the y direction, well, you take the impulse, which is 4.99, and you divide it by the duration that it was on the bat, which is 0.00185. And what you end up with is 2,697 newtons. And so that's the average force in the y direction. So you have to split this up. You have average force in x direction and average force in y direction.